Do moon rocks vanish into thin air? You might be surprised. Between the years of 1969 and 1972, the Apollo missions returned to Earth carrying a hefty 382 kilograms of lunar material. These weren't just ordinary rocks, they were fragments of the moon, precious samples holding secrets of our nearest celestial neighbor. But here's where things get puzzling. Over the years, several of these moon rocks have mysteriously disappeared. Some were stolen, others misplaced, and a handful even made their way into the black market. These weren't just trinkets you could misplace on a busy day, these were pieces of the moon. Theories abound about their disappearance, but the truth remains elusive. So are these moon rocks lost forever, or are they out there holding secrets of the moon's past? Have you ever imagined seeing flashes of light on the moon? Well, this isn't a mere flight of fancy. Astronauts during the Apollo missions reported this exact phenomenon, even when their eyes were closed. These flashes, known as lunar transient phenomena, or LTP, have sparked a fascinating debate in scientific circles. Now, some scientists propose that these flashes are caused by cosmic rays hitting the astronauts' retinas, which sounds plausible, doesn't it? But the plot thickens. Other theories suggest that these flashes could be a result of outgassing or meteor impacts on the lunar surface. The debate is far from over, and the true nature of these lunar flashes remains elusive. Every flash, every flicker, and every burst of light adds another layer to this cosmic enigma. As we continue to probe the moon's secrets, we're left with an intriguing puzzle. Until we know more, the moon's light show remains a spectacle shrouded in mystery. What lies hidden on the moon's far side? For centuries, this question intrigued astronomers and space enthusiasts alike. The far side of the moon, often mistaken as the dark side, remained elusive until the dawn of space exploration. This part of our lunar neighbor presents a terrain so vastly different from the side we see from Earth. It's heavily cratered and lacks the large, dark, basaltic plains known as maria that are visible and quite characteristic of the near side. Now, what could possibly cause such a stark contrast? Theories abound. Some suggest that the far side's crust is thicker, making it less likely for molten lava to reach the surface and form maria. Others propose that gravitational tides caused by Earth might have played a role. Yet, despite the multitude of theories, we are still far from a definitive answer. As we stare at the same moon, we can't help but wonder about the secrets its other side is keeping. Did you know the moon has its own magnetic hotspots? Despite not having a global magnetic field like Earth, the moon is home to localized regions of strong magnetism, known as magnetic anomalies. These anomalies are particularly potent in certain areas, including the Apollo 15 landing site. So what's the deal with these lunar magnetic quirks? Well, the truth is we're not entirely sure. Some theories suggest they could be remnants of a long-extinct lunar dynamo, a molten, rotating core producing a magnetic field. Others propose they might be the result of external influences, such as asteroid impacts. These magnetic anomalies are not just intriguing puzzles, they could also provide invaluable clues about the moon's ancient past. As we continue to explore and understand these magnetic mysteries, we are reminded that the moon, silent and motionless as it may seem, could potentially have a turbulent and active history. These magnetic mysteries remind us that the moon, silent as it seems, may have a turbulent past. What causes quakes on a tectonic plate-free moon? Now that's a question that has left scientists scratching their heads. Unlike Earth, the moon doesn't have tectonic plates, yet it experiences what we call moonquakes. These seismic activities on the moon are a true enigma. Some of these moonquakes are deep, occurring about halfway between the surface and the moon's core. Scientists believe these might be related to tidal interactions with Earth, but it's the shallow moonquakes, those that occur near the lunar surface, that are less clear. The theories range from the effects of the lunar surface cooling and contracting to possible ancient tectonic activity. However, the jury is still out on the exact causes. The significance of understanding these moonquakes is not only for scientific curiosity, it's crucial for future lunar colonization plans, because, as these moonquakes remind us, the moon is not as quiet as it seems. Water on the moon, a blessing or a new mystery? The discovery of water ice in the permanently shadowed craters, especially near the lunar poles, was indeed a thrilling revelation. But as with all things lunar, it's not as straightforward as it seems. The extent and distribution of this ice are still shrouded in uncertainty. And the origin? Well, that's another conundrum. Is this ice a relic of ancient comets and asteroids that slammed into the moon billions of years ago? Or could it be the result of some other yet unknown process? These are questions that keep lunar scientists awake at night. But why does it matter, you might ask? The answer lies in our future. If we are to establish a long-term human presence on the moon, we will need water. So understanding this icy enigma is crucial. The moon's icy secret could be a stepping stone to our future space endeavors. What happened to the lost lunar module of Apollo 10? It's a question that has lingered for over half a century. During this mission, a part of the lunar module, affectionately nicknamed Snoopy, was jettisoned into the vast expanse of space, seemingly lost forever. The Apollo 10 mission served as a dress rehearsal for the historic Apollo 11 landing, and Snoopy, once its role was fulfilled, was set adrift in the cosmos. Its fate remained a mystery for decades, a small but intriguing enigma in the annals of lunar exploration. However, recent efforts have breathed new life into this old mystery. Dedicated teams of astronomers and space enthusiasts have been scouring the skies, hoping to locate this long-lost piece of space history. The search for Snoopy is not just about finding an artifact, it's about understanding the trajectory and survival of human-made objects in deep space. Snoopy's journey is a testament to our everlasting fascination with space exploration. Why does the moon's soil behave so differently from ours? This question has been a conundrum for scientists trying to understand the moon's unique surface. The lunar soil, also known as regolith, is unlike anything we have on Earth. Lunar regolith is made up of tiny, jagged particles of rock and dust, created over billions of years by the relentless bombardment of meteoroids. These particles are so sharp and abrasive that they pose a significant challenge to human activities on the moon. For instance, during the Apollo missions, astronauts found that the lunar regolith could wear down spacesuits and clog equipment. But the challenges of lunar regolith go beyond its physical properties. It also behaves in surprising ways. For example, despite the moon's weak gravity, the regolith seems to clump together, forming a kind of lunar concrete. This behavior is thought to be due to a phenomenon called van der Waals forces, weak attractions between particles that become significant in the vacuum of space. Moreover, lunar regolith has an uncanny ability to jump or levitate. This is due to a phenomenon known as dust lofting, where tiny particles of regolith get electrically charged by the sun's ultraviolet light and then repel each other, causing them to lift off the surface. This behavior was observed during the Apollo missions, when astronauts reported seeing a glow above the lunar horizon just before sunrise, a phenomenon now known as lunar horizon glow. These unique properties of lunar regolith not only pose challenges to lunar exploration and colonization, but also provide us with fascinating insights into the moon's history and environment. They force us to rethink our understanding of soil behavior and to develop new technologies and strategies for future lunar missions. As we dream of stepping again on the moon, we must first unravel the mysteries beneath our feet. The behavior of lunar soil is one of those mysteries, a puzzle that we need to solve as we reach out to the stars. The moon, our closest celestial neighbor, continues to bewilder us with its enigmas, from the elusive moon rocks that disappeared under mysterious circumstances to the perplexing flashes of light seen by Apollo astronauts. The moon's far side, with its unique terrain and composition, challenges our understanding of this celestial body's formation and geological history. Then, there are the puzzling magnetic anomalies, the enigma of moonquakes, and the water ice conundrum, each raising more questions than answers. The search for the Apollo 10's lost lunar module, Snoopy, and the anomaly of lunar soil behavior also add to the list of unsolved lunar mysteries. These enduring enigmas are not mere scientific curiosities. They are keys to unlocking the secrets of our moon, keys that could reshape our understanding of the universe and pave the way for future space exploration. As we gaze at the moon tonight, let's remember that every crater, every rock, and every grain of lunar dust might be holding a secret waiting to be uncovered. Thank you for joining us on this lunar journey. We have explored many mysteries, but perhaps you have your own favorite moon enigma that sparks your curiosity. We encourage you to share your thoughts in the comment section below. Are there any other celestial mysteries you'd like us to delve into? Your feedback can help shape the content of our future videos. If you have enjoyed this lunar adventure and want to be part of more intriguing journeys, don't forget to subscribe to our channel. Until next time, keep looking up, keep wondering, and remember, the moon is always there, silently holding its secrets, waiting for us to uncover them.